Okay, a very good morning. I would like to wish to our computer programming lecturer, Mr. Rosmadi. Okay, and our group going to present on a project. Specifically, is computer programming project. Okay, before I start my presentation part, I would like to introduce our group members. First, my name is TIEW CHEE WEE. I will present about the theory part, and then followed by Leong Yong Hao and Loo Kian Sing. Okay, firstly, the aspect of study we focus is on piping system, in which the title is to determine the high difference between two tanks in one fluid flow system. Okay, next we are going to elaborate on the problem statements. Okay, the problem statement in this case is to study the required length and ensure the fluid flow in the allowable range of velocity, and hence the pipe able to withstand the flow rate along the process. In other words, we are going to study about the durability of this piping system as well as to eliminate any unnecessary wastage of material. Okay, in this report, we are going to focus on three main objectives. The first one is to identify the conditions in which make the fluid can flow in a smooth form. Secondly, we are going to study the case which the pipe can withstand the high velocity and flow rate of fluids. And lastly, we are going to focus on to examine as well as to research on how to increase the efficiency of fluid flow in a pipe. Okay, next, let's move on to methodology. In this case, I would like to briefly talk about the methods we are using in order for the system to run as well as to yield the outcome. Okay, I would like to illustrate one example. For instance, like for two-way selections, we can use either if-else, nested if statement, or even conditions, or for expression in this case. Most of the methods are used in our project in order for us to yield the outcome. On the other hand, for the multi-way selections, we have used switch statement as well as if-else if method in order for us to proceed and run the program in the following programs. And next, I would like to pass the presentation part to Leong Yong Hao for his flowchart part.
Okay, now let's move on to the flowchart. The flowchart will begin with the start, and then we go to the transition shape. The program will ask the user determine the unit. When the user input out of this six number, it will print out the error message and throw back and go back to the determine unit, this part. Let's say the user is key in the unit 1. The program will ask the user to key in flow rate Q1, and then we calculate the Q in this rectangle. After that, after we calculate the Q, the program will print out the Q. This situation is same with unit 1, unit 2, unit 3, unit 4, unit 5, and unit 6. After that, the program will ask the user to key in the diameter, and then we go to the connector A. The connector A will connect to the triangle, the rectangle part, rectangle shape. We calculate the area. Okay, after that, we will calculate the area and print it out. Before that, we already know Q, the value Q and the value A, so that we can find the value of velocity and then print out the velocity part. After that, after we find the velocity, the programming will ask another question to ask the user to key in the density and the viscosity of the dynamic viscosity, the mu. Okay. Then we'll calculate the Reynolds number by using this formula inside the rectangle. Okay, after we find the Reynolds number, we print out the value of Reynolds number. The program will make a decision: is it Reynolds number is smaller than 2300? If this statement is true, it will go to the another computation rectangle, which is this formula, and then calculate the value of f. After that, we flow to the print out the value of f. If the statement are a Reynolds number smaller than 2300, this statement is false. The program will make another decision. Is it the Reynolds number is bigger than 4000? If this statement is true, the input will ask the user to input the roughness ratio ER, and then we will find out the F. After we find out the F, we will print out again the F value. If these two statements is false, the Reynolds number is undefined, so the program will print out the transition flow and end the program. Okay, after this, the printout already print out the F value. Okay, the flowchart will connect to the connector B. The connector B will connect to the another input. The program will ask the length of the byte to calculate the major heat loss that inside the rectangle. After that, to print out the major heat loss, and then the program will ask the user to key in the K1. There is a coefficient loss, and then the program will make a decision: is it same with the case 1? Is same with case 1, K2 will be the 0.8. If not, it goes to the case B. The program will determine: is it same with the case B? If this statement is true, K1 will be 0.5. And then same with the case D. If true, K1 will be 0.03. If not, the program will ask will determine again: is it same with the case E? If true, K1 will be 0.12. If both case is not equal, if K1 is not equal to not inside the 4 case, then will print the error message, and then go to the input K1 and ask the user again. Okay, after we find K1, of course we need to print out it, and then you ask the user to input the K2. After you input K2, we'll connect to the connector C. The connector C, we connect to another software programming decision. If the input is equal to 1, okay, the program will determine again: is it Reynolds number is smaller than 2300? If true, if print out is straight away print out K2 equal to 2. If false, the program will print out K2 equal to 1.6. Okay, let's say the user key in another value, then the program will print out K2 equal to 0. Okay. After that, the program will ask the user, is it the bulb included 90 degrees smoke band fringe? If true, the program will ask, how many are there? The input, and then calculate the K3. After that, you print out K3. Print out the K3. If the user key in another value out of 1, then you straight away print out K3 equal to 0. After that, we connect to the connector D. Connector D. Okay, this one is similar with the statement just now. You will ask the user, is it included 90 degrees smoke band thread, 90 degrees middle band without winds, and 90 degree middle band without with winds, or 45 thread elbow, 180 degree return pin fringe, 180 return pin thread, and last, the program you ask the user, is it included thread unions? Okay, and this time we already know the K1 until K10. After that, the program will read K1, K2, K3, K4, K5, K6, K7, K8, K9, and K10 into array Kn. Okay, start with the Kn. Start with the n equal to 0. We're using the looping statement. Okay. Before n smaller than n bigger than the 10, the looping will loop again and keep repeat until we find the k total. The k total is the sum of the 10 value, which is the k1 until k10. After that, we find the k total, which is coefficient loss, and then we print out the coefficient loss, the total coefficient loss, and then with this value, we find out the minor heat loss inside this combination rectangle, and then we print out the minor heat loss. After that, we already know major heat loss, minor heat loss, and by using this formula inside this rectangle, we can find the total heat loss. After we find the total heat loss, we print the total heat loss and show the user the result of the total heat loss. And then the last part, you end the program.
My name is Loo Kian Sing, and I would like to continue our presentations with the school scope. This is our programs. Start with a no statements. State that this is a programs for determining heat loss or height difference of two tanks in one flow systems. And next, we will continue our programs with the standard C header files, which is the includes stdio.hash and includes mesh.hash. The stdio.hash is to declare types, macros, and functions for standard input and outputs, and the map.hash is to declare two types and several functions and define several macros for general mathematical operations. Then we process our programs with define the two variables, pi and also g. Next is the inment, which is the parenthesis used to indicate a function, and the bodies of all functions must be contained in the brackets here. Then we have to declare the variables before it can be used in the programs, like the integer data types or the floating point number. And we process our programs with a do-while loop. The loop's body is executed repeatedly until the return values of the controlling expressions is equal to zeros, which means that is not equal to the expression at here. We use the format input and output, which is the print and scan. Print is to instruct computer to perform an action. And the short end here is an escape characters, and is also a new line characters, which means that the lines after that will be present in a new line. And we use scans. The scans consists of format control strings of arguments, types, and also arguments. The format control strings using specifications to discrete input formats begins with a % sign. And next, we proceed our programs with the else-if statements, which is also a selection statement. The statements will exclude if the expressions compare to zeros. Else, if you move on to the another statement. This is the relational operators, and it's also an equal comparison, which means that the units is exactly the values beside it. Then we will ask the users to choose the units of the flow rate, and it's given 1 to 6 to choosing the units here. Then if your statements will choose the input, and it will print and scan it, and it will give us a formula for each value. It's arithmetic operators, which is the divisions. After that, if the value is not equal to 1, is not equal to 2 until 6, it will return back to the front of the do-while loop. This is the not equal comparisons under the relational operators, and this is the logical operators, which is the name logical ANDs. After that, after the users key in the values, we will proceed to another line, the following line, and we will decrease the D, A, V, RE density and U. After that, we will print out what is the value of the diameter emitter, and the users must key in the diameter. Then we will calculate with these equations, calculate the cross-sectional areas, and it will print out the cross-sectional areas of the pipes in here. As this is the format control strings, and this is the arguments. Followed by the velocity, it will calculate it by these equations. It will print the velocity of the fruits at this line. Then the computer will print out what is the value of the density, and the user must key in the density, and it will scan it. Then what is the values of the dynamic velocity, and users key in, and the unit, the value is scanned at here. Then the Reynolds numbers can be calculated by using these equations, and we'll print out the values of the Reynolds numbers. Now we have to declare the float F, which is the friction factor. We use else-if statements again. If the RE calculus is less than 2300, we will print is a laminar flow, and the frictional factors is calculated by this formula, and we will print the friction factors Else, if the RE is bigger than 2000, it will print is a turbulent flow, and we have to decrease E and ER, which means the roughness value and the roughness ratios. And we will print out what is the roughness values of the pipe materials, and we will scan the value the user key in. And this formula is given to calculate the roughness ratios of the pipe materials, and we will print out the roughness ratios. And the frictional factor is finally calculated by this formula, and we will print out also. If it is not less than 2300 or more than 4000, it will sprint is a transition flow, and it will move to the next line. There is no heat loss for transition flow, and it will go to A. Go to statements causes an unconditioned jump to the statements prefixed by the name label in the enclosing functions. A go statements can either transfer control forwards or backward within a function. And we go to A. Then it will go to here, and you will end the programs. If it is not less than 2300 or more than 4000. And next, we declare L and H measures, and it will print out. Please key in the value of the length of the pipe in meters, and it will scan the value key in. And the formula is given to calculate the H measures, and you will print out the measure loss at here. Then this is the go to statements. Then we declare C, char C, and we declare K1. And we will print if the entrant is ran entrant, key in A. If the entrant is sharps, else key in B. If the entrant is well round, key in D. If the entrant is slightly round, key in E. And you will scan the character key in. Then we use switch statements. Switch statements can cause us control to jump to, into, or past the statements. The expressions inside a switch statement depends on the value of the control expressions, the presence of the default labels, and the values of any case label or in the switch body. If it is case A, it will show the K1 is equal to 8, and you will bring the value of K1, and you will break, which means it is finished for the switch statements. But it's case B, case D, case E, it will print also the another value for each case and print out the K1. And the user is not keying A, B, D, and E, it will print invalid input, and you will go back to B, go to B at here. You will scan again. It will ask the users to key in again the characters. Then we declare the C1 and we declare C2. It seems at the above, but now we use the if else statements. It prints that if there is retrace sharp else or rounded exits, please key in once, or if not, please key in 2, and you will scan the value. If the user is key in once, and inside it, if the RE is less than 2300, it will show the value of K2 equal to 2, and we will print the value of K2. Else, which means that the RE is bigger than 4000 here, then it will show the KL is equal to 1.6. If the user is not keying once, it will show that K2 equals 0, and it will print the value of the K2 is equal to 0. Then we decrease all these variables, which is used in the following programs. Then we print out if there is 90 degrees move bend, press key in once, otherwise press key in 2, and we will scan the value. If it is equal to 1, it will show the values of the things we need to key in, and we will ask print out how many are they, and it will scan the numbers, and it will calculate the total of the care tree, and it will print out the value of the care tree. It sends for the another connector paths 90 degrees move bend types, 90 degree bending bends without bands, 90 degree bendy bends with bands, 40 degrees treated and browse, 180 degree returns band friends, 180 degree return band threads, and also the thread unions. If it is once, it will be a value at there. If it is not, the user is not keying once, the values is equal to 0 for each connectors of the byte. Then we're using one-dimension array with the tightness and the aspirations. Then we decrease it, decrease and decrease k total. Then we use for loops where expressions 1, 2, and 3. The expression 1 and expression 3 is evaluated as a vote expressions, while expression 2 is a controlling expressions, which means that if n equal to 10, the for loops will end. If not, it will continue runs. Okay, we use the for loop to calculate the total loss coefficient, which is the kt here. When the n equal to 0, which means that k equals to 1, then kt will plus k1, and by the following plus k2, plus k3, plus k4, plus k5 until k10. This is the increment operators, which means that once it go down and return back, it will add 1 to its operands. This is the relational operators, which means that kt equal to kt plus kn, and you will print out the value of the total loss coefficients, and we declare the hash minus, and the values is calculate by using these equations and print out here. Then we get the hash total, which is the height difference also, and the equations is given, and it will print it here. And this is the a go to a, which is from the outwards, which is decreased before, and if we end up our programs with return zeros and also the left bracket. Now let us run the programs. Okay, choose the unit of the following, the flow rate. The flow rate given in the equations is 2, which is the L's divided by minutes 2. Then it will print out the pre-key in the flow rate as shown in these programs. If the L is, if the unit is equal to 2, it will print out pre-key in the flow rate. The flow rate given is at 3.3. We we key in, and we will calculate the Q, and it will print out, and here the flow rate is 0.00138 m cubed per second. Because it's equal to 2, so you will move on to the other line, and it will ask us what is the value of the diameter in meters, and the value given is 0.02, and the cross-section area will be calculated and will be print out. The velocity will also be calculated and print out, and it will ask us the value of the density. Okay, the density is 997, and it will ask us the dynamic viscosity. The value is 0.000891, and we press enter. It will ask. It will print the values of the Reynolds numbers at here, which is calculated by these equations, and we will move on to other statements. Okay, as the Reynolds numbers calculated is bigger than 4,000, and you will print out it is turbulent flow, and it will print out also what is the roughness value of the pipes materials, and we have to key in the roughness value 0.000002. Then it will print out the frictional factors calculated by these equations. Okay, then it will move to the another statement. Ask the users to key in the value of the length of the pipes in meters, and it will calculate the major loss. The value is 55. Then it comes to another statement. If the entrance is rentrance, key in A. If the entrance is sharp else, key in B. If the entrance is well round, key in D. If the entrance is slightly round, key in E. The entrance is sharp S, so we key in B. By using switch statements, it will show that K1 is equal to 0.5, and it will break, and if moved to the following program, it will ask us if they are the connection parts. This is the connection. No, this is the Reynolds stress entrance or rounded axis. If there is pre-scaling 1, if not pre-scaling 2, there is the sharp edge in the problem statement given, so we press in 1. Then the R calculate is bigger than 4,000, so it will come to this else. K2 equal to 1.6, and we will print the K2. Then if we move on to the connection parts of the pipes, if there is the connection parts of the pipes, key 1, otherwise pre-scaling 0. For the 90 degrees movement friends, there are no, so we key in 2. So it will print out the value of K3 is equal to 0. It sends to the 90 degrees movement tree, which is also no. For this one, without Venice is also no, so we key in 2. And the 90-degree bending band with Vance is also not given in the problem statements. But for this ones, 45 degrees straight tempo is given, so we key in 1, and there are 2 inside it. And the total of the K7s is calculated by these equations, and you will print out the total K7s. is equal to 0.8, which means that 0.4 times 2 equal to 0.8. Then the following connections of the pipes is also not given, so it's 2 for every connection below. So we key in 2, and the values is also given 2. Okay, until the last part. After we key in 2, it will automatically calculate the total loss coefficients, and you will print out the value of the total loss coefficients, and it will print the value of the minor loss, and also print the value of the heat loss with the equations given here, and we will return zeros, and our programs will exit codes. And this is the final answer we get, which is the total heat loss and also the height difference between two pipe systems. And this programming is proven that we successfully built it. I would like to end our video presentations with the conclusions. The C programming is essential in our study life as well as in the future working periods. It helps us to simplify a lot of equations, facilitate the entering of the data, and yielding of the outcomes in most of the cases. That's all from us. Thank you for watching our video presentations.